Let's welcome the second speaker, Dr. Shuichi Obuchi. And Dr. Obuchi got his PhD from Kitasato University, Japan. And he's now the chief researcher in the Tokyo Metropolitan Institute of Geriatrics and Gerontology in Japan. And also he's the adjunct professor and the director of the Management of Frailty, Faculty of Sport Sciences, Waseda University. So and he's going to talk about an attempt to develop a digital biomarker for frailty. So let's welcome Dr. Obuchi.
Good afternoon, ladies and gentlemen. It's my pleasure to having you presentation. I'm very thankful to NHRI. Today, I would like to talk about our attempt to develop a digital biomarker for frailty with these kind of wearable devices. Neither of our members did not have any financial support from the institute, other institute. Today, I would like to talk about a little bit, briefly explain about our recent researches, then the attempt to use this kind of measurement system to detect the frailty and non-communicable disease. And this project is done by our research institute and geriatric hospitals. So we are collaborating with the doctors and scientists. Let's talk about the background a little bit. This is the early strong predictors of decline in instrumental activities of daily living, which means 4 years IADL decline. What kind of factor is most closely related to the IADL decline, including almost all of the comprehensive geriatric assessments. It's including hand grip strength and the standing time and walking speed, maximal walking speed and time up and go time, and also the oral function. And here is a repetitive swallowing test. And here the dietary variety score, geriatric depression scale, and WHO-5, and also a mini mental state exam, and Raven social network scale, which means it covers most of that aspect. And we found as the yellow here that these kind of the walking related indices is the strongest predictor for the 4 years decline in IADL. So maybe that if the researcher, you or the researcher of the frailty field, you all agree with the walking speed is a very important factor to predict predictor. But the problem is to measure the walking speed, we need to the certain kind of walking path, and also we need a special laboratory technician who measures that the walking speed. The nurse or others cannot do that. So that's the problem, so that the clinicians did not use that kind of the walking speed for the everyday diagnosis. So what we do is we try to use this smartphone system, whether this system can be measured like walking parameters without any intention of the subject. Actually, the smartphone has a step counter in the very basis of the OS level. And also, this one has a GPS system. So if we understand the person walking steadily, we can measure that length of the walking, and also we can measure the speed, time of the walking, so that we can calculate walking speed and step length and cadence, and the cycle as well. So in this system, the application system the monitors the step counters every minute, then find out if they are walking or not. If the system understand it's walking, they ask the GPS system on, then every 20 meters of straight walking, if the person did not walk straight, it's omit that the data. Every 20 minutes of walking, they measured, they calculate the walking speed and the step length and so on. Then after that, all correction, the application send those data onto the cloud in once a day. Using this system, we did a series of the researches, whether this is compatible to the gold standard measurement, which is using stopwatch. We found 84% of agreement with the smart stopwatch measurement, and also I thought that we did not know about the distribution of this kind of unintentional walking. So someone, in a hurry, it should be more faster. But if they have a time or they walk with the children, they should have a slower speed. So the distribution can be a two-fold or any distribution. But so I did about 1,000 people asking use this system, then compare their distribution of the walking speed. Then I found that the walking speed is more normal distribution type. So that if we see that the mean walking speed, you can tell that their regular walking style. So I thought this can be used as a biomarker of the person. It's not affected so much by the social or environmental factors. Then I did a retest reliability, and also and then I found a very good retest reliability of the system. Then move on to I get the reference value. I had 15,000 participants using this system, age from 20 to over 80 years old, so that I calculate that each of the group, the standard, I measure that I published that reference value of from 20 to 80. Then I just wondering if this system can be used as a frailty measurement or not. So I did a measure. I asked our cohort person to use this system, and then the value from our system could be explain the frailty category or not. And it is about good as the stopwatch measurement. And also, I did some intraday validity and seasonal validity. The interesting thing of seasonal variability is walking speed is highly related to the temperature of the environment. Do you think which is faster? The colder is the faster, or the warmer is the faster? That I found is the colder the faster. So that is kind of regulated by the midbrain function that I believe. So I did that kind of things. So I'm more sure that this walking speed measured by this system could be a biomarker. Then, after the pandemic of COVID, I did some clinical researches about whether they changed their activity or not. Now, so I'd like to move forward to use this kind of system to the frailty. But frailty, as you know, frailty is not the concept of physical functioning. It also should include social functioning and others, mental function, cognitive functions, oral functions as well. So we attempted to compare this kind of cohort study to this kind of the lifelog data. We used the smartwatch here and asked the participants use the ankle band type of walking speed measurement. All these data go to the smartphone. Then subjects were asked at least 3 months of using this system. In fact, the study is started from last year. 60% of the participants still using this system, although they can be withdrawn after 3 months of the research. Then this part here is the cohort study here. We did a cohort study every once in a year, but the problem is maybe you encounter that kind of problem. If you ask the community dwelling person, there is not so many frail person or MCI persons. So this time we have a frailty outpatient clinic in our hospital. So we include that they are registered person with the regular cohort study. So we have about 600 the cohort the participants, and also we have 500 of outpatient. Of those, we are asking whether they would like to use this kind of a system or not. And and we had about 1,200 of participants accepted to use this system from the about 7,000 of the possible participants. So if you're looking at the difference between user and non-user with the assist of some statistical analysis, you can compare whether this kind of system is effective or not as well. Then, using these kind of data, it's huge data, so I cannot calculate by my hand. So I asked the AI system whether they are frail or not. So the main outcome is physical frailty, cognitive frailty, and social frailty, and also non-communicable disease. And good things of the smartwatch is not only measure the physical functioning, but also measure some social aspect, which is verbal, the length, duration of conversation time, conversation duration, We have a number of steps, gate speed things, and body temperature, and energy expenditure, and heart rate. Yeah. And also, to send the data to the crowd, some of participants did not have the smartphone. So I asked the gateway to send the data from these devices to the cloud. On that, the gateway, it has environment sensors that can be tell how cold and how much pressure, how much CO2, and so on, how illuminance, how bright it is. So I think this kind of, combined with this kind of information, we can understand some aspect of social functioning as well. And these are the health outcomes. This is more common, so just skip this part. So we have we asked the person asked to use the device is our 1,200. Of those, about 74 persons are agreed to use this system. Within those, about 54% is robust, and 62% is peripheral, and 7.7% is frail. So we use that the frail outpatient clinic, but still we have a small number of frailty persons. We use the CHS criteria for determining the frailty. This is the overview of data collection. Subjects are asked to use the devices about a year, but if the person did not want to use it, they can withdraw after 3 months. Then every year we are going to have a cohort study. We are now here. And after that, we are hoping they still continue to use this system. This is a data from these participants of the 3 months of data recordings. You can see here, heart rate is not different between robust, peripheral, frail, but energy expenditure, they don't move so that the frail person has a lower energy expenditure, but sleep is much more, but talk, this is the interesting part, conversation with the person is, the frail person is much higher. This is, it is not I expected, but maybe a frail person would like to communicate somebody, but also I found, I tried to look at the hour by hour analysis. The talking time is started at 7 o'clock and 12 o'clock and about 6 o'clock. It's increasing the talking time. So that I think, that these frail person have to have some kind of assist for eating or something. So they communicate with the carers. That's my understanding. But I don't know that's true or not. But you can see the significant difference between groups. In the female, there is not so many difference, but the tendency is the same. This is the traditional type of analysis of this kind of data. I think this is the more focused on amount of the activity. So combine these data and compare the mean value of these things, we found that significant difference. I put the color on the significant difference. So activity calories and metabolic rate, sleep duration, and total steps are significantly different. Sleep duration is increased. But I use this kind of the data put into the machine learning. But as you see here, the accuracy of these data are less than 60%. Maybe the conventional research had a much higher accuracy, but they don't use the validation study. They are using same data set, making the model and then validate with the same data set. So it's overestimate accuracy. But this types of analysis, we use the independent data set, that it was less than 60%. So to me, the traditional type of analysis is not enough. So what I do is we call this is tapestry analysis. This is my data here. This is walking the habit. I get up early in the morning at 6 o'clock, then move lifestyle walking, which means I do some the household works, and from the 6 o'clock to the 8 o'clock, then go to the job. So I have a steady walking here, and then get to the research institute and sitting all the time. Then in the lunchtime, I go out, things like that. If we see this kind of the character pattern, person by person, we can understand more their social pattern or things. So that's the idea. So I put the green light shows the walking over 1.1 meter or higher. And this is from day 1 through day 30. This is the combination of 30 days of measurement from 0 o'clock to the 24 hours. So looking at these kind of the measurement, the picture, you can understand their pattern easily. So using this tapestry, I did more the deep learning. This is a typical type of the tapestry data. Robust individual has a clear signals, and this case B has a very intense the lights in the morning, so he may walk every day. But see here, frail persons did not have much lights, and also the pattern is odd. Using that information, we start the research last year, so we did not have a good enough time to analyze. So I just a quick try using LessNet 50 and using sleep, and then whether it can be classified frail, robust, pre-frail. Then the result is much better than the ordinary type of analysis. Ordinary type of analysis could not distinguish between frail and pre-frail. But this type of analysis mostly distinguish frail and robust. But robust and pre-frail is, I think it's confusing the definition, I think. There can be revert, convert easily. So right now, we are not have enough accuracy of that system, but I would like to do that things more. This is the result from that the deep learning. The actual is the real measurement and predicted it from the AI. This slide shows the actual measurement is robust, but the AI predict as a pre-frail. But see here, in this pattern, you can see the person sleep in the daytime a lot. So the actual measurement is 0, but predicted to the frail. So maybe AI understand more than the things. I did some other group-based trajectory modeling. Like if we do that kind of analysis, we can do that if person use this system. This is the from 100 days, 3 months, and then if we look at the trend of the person, that if the person increased, let's say step by day increase this way, that means they are affected by this kind of the system. So you can also understand they are tolerate with, they have ability to change their life or not. So conclusion, we are doing in the middle of the research, but we would like to do to find several aspects of the frailty. Of course, if we measure this kind of motion analysis, motion activity analysis devices, we can understand the quantity of the activity. But if we use that kind of tapestry analysis, we may understand the quality of activities. And also our challenge is maybe I need to find the social aspects as well. So that's our attempt. Thank you for your attention.
Thank you very much, Dr. Obuchi. So we'll still save your question to the end of the session. And so then next, Dr. Zhang will chair the next 2 speakers.